So any doubts in this? Any doubts in this? So next we'll solve one more problem. Calculate the mole fraction of just wait a minute. So calculate the mole fraction of H2SO4 in a solution containing 98% H2SO4 by mass. Okay, how to calculate this one? Calculate the mole fraction of H2SO4 in a solution containing 98% H2SO4 by mass. How to calculate? So first, what is the mole fraction formula? Mole fraction formula is what? Mole fraction of H2SO4 they are asking. So if you take here, solute is the H2SO4 and solvent is the water. Okay, and they said 98% of H2SO4 by mass. Then what is the meaning of that 98% of mass? What is the meaning? 98 grams of H2SO4 in 100 grams of solution. That is the meaning. Okay, so solute is how much? Weight of the solute is 98 grams, and weight of solvent is how much? 2 grams. So these two are adding now, you'll get the weight of the solution. Now, molecular weight of solute. So molecular weight of solute how much? H2SO4 2 plus 32 plus 64. Approximately it is equal to 64 to 64. This is 32. How much approximately? 98. Okay. Now Na value. Na equal to given mass by molecular mass. Which is equal to 98 by 98 is equal to 1. Okay, so Na is 1. Then what is the molecular weight of water? 18 grams. So that is Nb. Nb equal to how much? 2 by 18 is equal to 1 by 9, which is approximately equal to 0.11, right? This is a Nb value. Now if you want Xa now, that is a mole fraction of H2SO4. How to calculate? Na by Na plus Nb, which is equal to 1 by 1 plus 0.1. What would be the answer? What is the answer? One by 1.1 approximately equal to 0.9. Okay. So this is how we will calculate the mole fraction of the H2SO4. Any doubts in this problem? Yeah, good. 0.9. So next one. We'll solve with another formula. Calculate the molality of 1 liter solution of 93%. Okay, H2SO4 volume by volume. The density of the solution is 1.84 gram per ml. Then how to calculate for this? You have to calculate the molality of 1 liter of calculate the molality of 1 liter solution of 93% H2SO4 volume by volume. The density of the solution is 1.84 gram per ml. So what is the molality formula first? See, Vishwanath, only you are there in the class. So unmute yourself and reply first. What is the molality formula?
Liter. Kgs.
Molality is equal to number of moles of solute by what is the formula?
Number of moles of solvent.
Mass of the solvent. Yeah, reply like that. Okay, now what is given data here? What they said? 93% H2SO4. That is volume by volume, right? That means what have to take? 93 grams or 93 ml? Volume na ml you have to take. So 93 ml of H2SO4 in 100 ml of solution. Understand it?
Sir.
Now we got the value of the solution is how much? 100 ml. Volume of solvent is how much? 93. Sorry, this is not the volume, this is the weight. So if it's the weight now, this we should take in the grams. So 93 grams of weight by volume they said. So 93 grams of H2SO4 in 100 ml of the solution.
Sir.
Okay. So tell me what you have to do next.
No idea.
Hmm? To calculate the molality of 1 liter solution of 93% H2S of weight by value, density of the solution is 1.84 gram per ml. Then what we can do now? They said weight of the solute is how much? 93 grams, and the volume of the solution is 100 ml. But we don't want the volume of the solution, right? So from that, we already get the mass or density also. So density is equal to mass by volume.
Sir.
So if you want mass of the solution now, what we can do? Density into volume of solution. Okay. So if you take this density as a 1.84 and volume of solution is 100 now, then what is the mass of the solution? In grams? 184.
94.
Okay. Now, if you want mass of the solvent now, what we can do? Want only mass of solvent. What we can do? Mass of solution minus mass of solute, right? So mass of solution is how much? 184.
184.
Mass of solute how much? 93. Right?
Sir.
So 90 will come answer. So 91 grams is the mass of solvent. Fine. And number of moles of solute. So now we use the molarity formula here. M equal to number of moles of solute means given weight by molecular weight into 1000 by
1000.
mass of solvent in kg, in grams. Given weight how much? 93. What is the molecular weight? H2SO4? 98, right? Okay, so 93 by 98 into 1000 by 91. If you solve this one, you'll get the answer. Can you tell the answer? What is this?
Sir, 10.4. Sir.
10.4 mole per kg. Okay,
Sir.
so this is what the molarity formulas and all. Okay, so next we'll study the new concept today, that is the normality. Do you know what is the formula for normality? Normality is capital N, which is equal to weight of solute by equivalent weight of solute into 1 by volume of solution in liters. So normality is nothing but weight of the solute by equivalent weight of the solute into 1 by volume of solution in liters. That is the formula for normality. But how to find the equivalent weight? If you write the molarity formula, now it is also same. Weight of solute by molecular weight of solute. So what is the difference between the normality and molarity? Normality will take equivalent weight of the solute. Molarity will take the molecular weight of solute. The remaining everything is same. Only this part is same. Then how to find this equivalent weight? Again, you have one more formula. Equivalent weight of solute is equal to molecular weight of solute by m factor. Okay, this is the formula for the equivalent weight of solute.
Sir,
Okay, what is the meaning of n factor then? So n factor we'll write here. For the acids, n factor is equal to number of replaceable hydrogen atoms. Okay. Suppose if we take H2SO4, what is the equivalent weight? What is the equivalent weight of H2SO4? The equivalent weight is equal to molecular weight by n factor, right? So if we take H2SO4, what is the n factor here? Number of replaceable hydrogen atoms. What is the meaning of replaceable hydrogen atoms? If you draw the structure of H2SO4 here, it will be like this. There is a structure for the H2SO4. The number of replaceable hydrogen atom is nothing but whichever the hydrogen atom directly attached with the oxygen. Hydrogen atom directly attached with the oxygen is called as an replaceable hydrogen atom. Okay.
sir,
Whichever the hydrogen atom attached to the oxygen directly, that is a replaceable hydrogen atom. Now you tell me how many hydrogens are attached directly to oxygen here in the case of H2SO4?
2, sir.
2. Okay. So what is the molecular weight here? 98 by n factor is 2. So here what is n factor? 2. That means equivalent molecular equivalent weight of H2SO4 how much? 49, right? Understand? Okay. So next we'll come for the like a salt we'll take. Any salt we'll take. Okay. So here n factor. Just wait a minute. Here n factor is equal to charge on metal atom. It is common. Equivalent weight is equal to molecular weight by n factor, but n factor is what here? Charge on metal atom. Suppose you have taken like a ZnCl2. How to find the equivalent weight? Molecular weight of ZnCl2 by n factor. But if you dissolve the ZnCl2 in water, what you will get? You will get Zn plus 2 plus 2Cl minus 1. What is the charge on metal atom here? What is the charge in metal atom here? Hmm? What is the charge in metal atom here? The +2, right? So n factor will be what here? Two. So didn't CL to weight how much? Zinc is 65. CL is 35.5. So both are adding a 71 you'll get. So how much? 136. So 136 by n factor is 2. So equivalent rate of Zillion CL2 is how much here from this calculation part? 63 to 67 to 68, right? This is the way calculate the equivalent rate of Zillion CL2. Understanding?
Sir.
Now we'll do one problem on this. .75 grams of sodium bicarbonate. What is the formula for sodium bicarbonate? What is the formula? What is the formula for sodium bicarbonate? NaHCO3 is the formula for the sodium bicarbonate. Okay. So they're asking to calculate the equivalent, normality they are asking and molarity they are asking. And one more relationship between the normality and molarity is normality is equal to n factor into molarity. Okay. Now you tell me first we'll calculate the normality only. Which is equal to weight of solute by equivalent weight of solute into, here it is given in the ml. That means 1000 by volume in ml. Okay. Already we know weight of the solute is how much? 0.75 grams. Fine. Only we have to find out the normality, means equivalent weight only we have to find out now. Okay. So equivalent weight is equal to molecular weight by n factor. So if you dissolve the NaHCO3 in the water now, it will form Na plus 1 plus HCO3 minus 1. That means what is the equivalent weight here? This one. This is a plus 1 actually. So sorry, what is n factor here? Plus 1. Okay. Then molecular weight only you have to find out. What is the molecular weight of NaHCO3? Find out. Sodium 23, hydrogen 1, carbon 12, oxygen 16, 16 3 is 48. So if you add all the things, what you'll get? Hmm? 84, 8, 12, 14, 84. Okay, now the substitute here. So equivalent rate is how much? 84 by 1 is 84 only. 84 by 1, that is equal to 84. Substitute here 0.75 by 84 into 1000 by 250. You'll get the answer. How much you'll get? 0.75 into 4, right? So if you want the 254, 4 to the 4 ones, so 0.75 by 21. So
0.035.
0.0357 normal. Understand now how to calculate the normality? If you clear with this, how to calculate the equivalent weight, it will be easy for you. That's all the difference. Okay, next one, molarity. So if you know the normality, you can calculate the molarity also, right? Molarity is equal to, normality is equal to n factor into molarity. We know already normality. How much? 0.0357 divided by n factor. N factor how much? 1. So molarity is equal to 0.0357 by 1. That is approximately equal to molarity how much? Same. Okay. This is how we'll solve the problems. Any doubts in today's class? Hmm? Did you wrote the test today?
Yes, sir.
We didn't attend the test till now. Okay, just to find out the answer for this, one more problem. In the next class, I'll start the new topic because today no one is there, right? By prepared, I'll start in the next class. So calculate the mass of urea, NH2CO, NH2 required in making 2.5 kg of 0.25 molar aqueous solution. Find out the answer for this. To understand the question first,
Sir.
what formula you have to use? Hmm? reduce molarity formula. So molality is equal to weight of solute by molecular weight of solute into 1 by mass of solvent in kgs. Okay, just you have to find out this weight of solute. They are asking this weight. From this urea, you can calculate the molecular weight. NH2CO, NH3. Okay, this is approximately 60 you will get. Yeah. So this weight you want now, what you have to do? Bring all that state molality into molecular weight of solute into mass of solvent, and that's all by 1. So 0.25 into 60 into 2.5, you'll get the answer. Okay, remaining things we'll discuss in the next class. This meeting is going to end also now today. Okay. Just so you can practice the problems and all. We'll know what we